All right, so in lesson 911, we learned about solving inequalities with one variable. And you can see that I've already done the first example. It's a single variable. I added 7 to both sides, one step. I got x is less than 5. So I did an open circle on 5, pointing to the 4 and the 3, which are values worth less than 5. Now, the second one, b, you can see that I've already started to solve, but there were variables on both sides. So first I subtracted 3m from the left and the right. And then I added 8 to the right and 8 to the left. I can do that all in one step. My goal is to get rid of all the variables on the left, move them only to the right. So I would have 5m on the right. My less than or equal to stays a less than or equal to because I did no multiplying or dividing on both sides. And the plus 8 with the plus 2 is positive 10. At this point, I'm going to do the second step, which is to divide both sides by 5. And I'm going to get 2 is less than or equal to m. Now, what's interesting about that is that the inequality is sort of backwards. We really want to have the variable on the left. So if I put the variable on the left, you'll notice that the open part is close to the m. So when I rewrite it, the open part stays close to the m in order to be worth the same. This one said 2 is less than or equal to the values of m. This one says the values of m are greater than or equal to 2. They're saying the same thing. If I put 2 in the middle, because it's got the equal to bar, I'm going to do a closed circle. I'm going to put 3 and 4 to the right, 1 and 0 to the left. M is greater than or equal to 2. That will be pointing towards the right. But you'll also notice 2 is worth less than or equal to values of m. The 2 could be equal to because it's colored in, but it is less than all the values up in that arrow. So it can actually be read either way. Now the next one equation, I would start by getting rid of any addition first. Think of PEMDAS in reverse still. I would have 2/3 p is greater than negative 2. I haven't multiplied or divided anything, so that greater than stays a greater than. Now, because it's a fraction, I'm going to multiply both sides by the reciprocal. So the reciprocal of 2/3 is 3/2. On the right, multiplying by 3/2. If you want, you can put the negative 2 over 1 so you can kind of see the fraction times a fraction. And you're going to have that p is greater than the negative 2 and 2 can simplify. So I've got negative 1 times 3, which is negative 3. Now, the number that I multiplied both sides by was a positive 2/3. So the greater than stays a greater than. I'll put negative 3 right here in the middle with higher numbers to the right, lower numbers to the left. The negative 3 is going to get an open circle, and it's greater than, so I'm going to point to the right up where the 0 and the positive numbers would be. Now, also notice it's open because there's no equal to. D, 2 is less than, and then you can see the 3 has to be, 2 subtract, and then the 3 has to be distributed to the x minus 1. And on the right, there's another variable. So this is one of those multi-step problems. First, I'm going to simplify the left side by distributing that negative 3. And I'm also going to simplify the left side by combining any like terms. And at this point, I have an x and a constant. I have a term over here on the right with an x and a constant. I'm going to get all of my x variable terms to the right. I'm going to add 7 to both sides to get everything that does not have an x over to the left. I'm going to have 12 is greater than or equal to 4x. When I divide both sides by 4, you'll notice that I have that backwards inequality again. 3 is greater than or equal to x. I'm going to rewrite it with the x first, the small part of the symbol next to the x. So when I rewrite it, the small part stays next to the x. X is less than or equal to 3. 3 goes in the middle. Smaller numbers to the left, larger numbers to the right. Greater than or equal to, so I shade in that closed circle. And a less than would point down towards numbers smaller than 3. So this one has a closed circle because of the equal to. Now here are our special cases. You'll notice that this has variables on both sides again. I'm going to follow the same set of steps. First, I'm going to simplify both sides by combining any like terms. At that point, I'm going to try to get the 2k and the 7k is 9k, not 5k. I'm going to try to get all my variables on the same side. So when I go minus 9k, you'll notice that all I have left is negative 3 is less than or equal to negative 3. I have no variables. I have nowhere to substitute any numbers. And this statement is a true statement. Negative 3 will always be less than or equal to negative 3 because of the equal to part. So When you get to a point where you have no variables left at all, and the left side will always make the right side true, a true statement, I should say, -3 will always be less than or equal to -3. There's nowhere to plug anything in. You can say that the solution is all real numbers. And you have to be careful that there isn't still a variable left somewhere like a 9k minus 8k, which is just k, that you would have to continue solving. So what does the graph for all real numbers look like? You can put any 5 numbers you want. Most people center it around 0, and you just do a line that has arrows on both ends, and you're basically saying that all of the numbers on the number line are solutions. No number gets a circle. The one on the right, F, if I subtract 3y on the left and subtract 3y on the right, again, you will notice that all of my variable terms cancel, but this time you'd be left with +1 is less than +1. And that is not a true statement, and there's nowhere to substitute anything. When you get to a point where there's no variables left and it is not true, then you would say that there is either no solution or that the solution is no real numbers. And then in order to graph that, all you do is you put the numbers on the number line, but you don't put any circles, you don't put any arrows, you don't put any rays, you don't put any segments. It would just be an empty number line. So I do want to explain question 9-15, which is the question that says United Nations. And this one says, at the end of this chapter, your team will have the exciting responsibility of representing a country at a special meeting of the United Nations. The UN needs your help preparing for future large-scale disasters. You will need to help find a solution that not only works best for the country you represent, but that also accommodates the needs of each of the other countries. To prepare you for this task, the next several lessons will present daily problems to familiarize you with the important issues and concerns of other countries. Write and solve an equation that represents the problem below. Use A equals number of member states in African group. There are a total of 193 member states, countries in the United Nations as of 2014. The member states are divided into regional groups. So write an expression for each group. The Asia group has one less member than the African group. Well, you'll remember up here it said A equals number of members in African group. So the African group numbers -1 would be the Asia group has one less member than the African group. Eastern Europe has 4 less than half the Africa group. So we can either do half A or we can do A divided by 2. And then to get 4 less, we would subtract 4. Both of those answers are acceptable. The Western group has 6 more than Eastern Europe. So you'd need your answer from part B, and then you would just add 6 to it. The Latin American group has 21 less than the African group. So the African group's number, whatever that may be, -21 would be 21 less. One country is in no regional group at all. That's just the number 1. It wouldn't reflect at all on any sort of relationship to the African group. How many countries are in each of the 5 groups? So you would have A for the African group, our next expression A-1 for the Asian group, our next expression 1/2 A-4, that was for the Eastern Europe group. The next one here that's in brackets, which is a little bit longer, that was for Western Europe. Then you've got in parentheses A-21 for the Latin American group, and the one extra country that is not in any region at all. Total 193, and that 193 comes from back here, total of 193 members. When you combine all your variables, you get 4A plus -23 equals 193. I added 23 to both sides and got 4A equals 216. When I divide both sides by 4, I get A equals 54. Now that would then have to be plugged back into each of the original expressions. A equals 54 is for the African group. -1 gives us the Asian group. Half of 54 minus 4 gives us Eastern Europe. Then if I add another 6 to that, I get Western Europe. If I take the African group -21, I get 33 for the Latin American group. And that last one that had no group at all. All right. In 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Similarly, the nation of Cameroon plans to give flowering sata trees to other countries this year. I'm not sure if I pronounced that correctly or not. When asked how to decide which sata trees make good gifts, Cameroon's chief arborist explained, "We plant the trees when they are 6 centimeters tall and they grow 9 centimeters every year. The trees only flower when they are taller than 150 centimeters. It's very important that the trees Cameroon gives flower this year. It would be considered an insult to receive a tree that did not bloom. Luckily, Cameroon has many groves of sata trees from which to select its gifts. How old must the trees be so that they flower within the year?" So the first question is this an inequality or is it an equation? And if we go back to the quote, taller than 150 centimeters, that tells us that it's going to be an inequality. We're probably not going to be able to find many trees that are exactly 150 centimeters, but as long as it's taller than 150, it should be good. Write and solve a mathematical sentence to determine how old the trees can be so that they flower this year. So we plant the trees when they are 6 centimeters tall and they grow 9 centimeters every year. So that 9y, I would say y equals number of years old. You could have picked any letter that you wanted. And it has to be that height, the 6 centimeters when we plant it, plus the 9 centimeters per year, has to be greater than 150 overall centimeters before we're going to use it as one of the gifts. So we're trying to figure out how old the tree should be. So if we solve this inequality, and it's 144, divide both sides by 9, y should be greater than 16. Now, y stood for number of years old. And so we are going to say the trees should be more than 16 years old. And that's a pretty long commitment to wait 16 years for a tree to be available as a gift. I almost forgot to tell you, when the trees become very old, they stop flowering. Make sure you choose trees that are no more than 240 centimeters tall. So if we use the same start to the inequality, but say we've got kind of an upper cutoff, no more than 240. So 240 would work. We just don't want it to be more. So we want the height of the tree, all this stuff on the left, to be less than or equal to 240, because then I should get an age that is sort of like the cutoff. I shouldn't give a tree that's any older than, take away 6 from both sides, 9y is less than or equal to 234, and divide both sides by 9, y should be less than or equal to 26. Now, if we put these two facts together, we would say the tree should be more than 16 years old, but only up to 26 years old. And you'll notice that the symbols are different, right? This one's greater than, this one has less than or equal to. We can put those together in an interval. 16 is our lower cutoff. 26 is our upper cutoff. We said 26 was included. We said 16 was not. Remember, both less than symbols because we're in between the two numbers. And in this case, we would put a y because y stood for number of years old. And this is one way to sort of get into the idea of, how do we satisfy more than one condition at a time?